The second measure of spread that we're going to talk about is called the standard deviation. In a set of data, the standard deviation shows how the data deviates from the mean. A low standard deviation indicates the data tends to be very close to the mean, while a high standard deviation indicates the data is spread out over a large range of values. So like we have said in an earlier video, you can have two sets of data with the same mean, but they can be one set of data can be much more spread out than another set of data. The standard deviation really shows you how spread out a set of data is with a particular score. So the standard deviation is represented by the lower Greek letter sigma, and that is what a lowercase sigma looks like. It almost looks like a cursive O that you may have written when you were in elementary school. The variance is sigma squared of the data, is the square of the standard deviation. You actually find the variance before you find the standard deviation in the way that we're going to find standard deviation. So you can see the process for finding it, and it looks like it's pretty involved, especially when you look at that formula, but we're going to break it down into a little bit simpler pieces. But the first step in finding standard deviation is to find the mean, and then it says X bar. In statistics, anything that has a bar over it, a bar represents the mean of a data set. You see a bar, it is representing the mean of a particular data set. Then it says find the square of the difference between each data value and the mean, x bar minus x sub n squared. That's the biggest part of the process for finding the standard deviation. We're going to break that down into simpler parts here in a second. Step 3, find the sum of all the values in step 2. Step 4, divide the sum by the number of values in the data set. This is the variance. And then step 5, take the square root of the variance. And then it gives you the formula that we're going to break down. So we're going to find the variance and the standard deviation of this data set. Ed surveys his classmates to find how many electronic devices each person has in their home. Find and interpret the standard deviation of the data set. So the first thing we're going to do is to find the mean, because that is the process in defining the standard deviation. That's step 1. So to find the mean, we're going to add this entire data set, and it doesn't matter what order it's in. It can be in any order, because it's not like the 5-number summary where we got to find the median and put things in order prior to that first. So we just need to add all of these together. So you'd add 9 plus 10 plus 11 and so on and so forth. So you'd add the entire data set. When you add the entire data set together, you get 135. And then you would divide 135 by the number of pieces of data we have. We have 15 numbers in there. So 135 divided by 15 equals 9. So the mean of this data set, which again I'll just call X bar, is going to be 9. We're going to use the mean to help us find the standard deviation. So this is that step 2 that I said we're going to break down. So I'm going to create a 3-column chart here. In the first column of this chart, I'm going to just write down all of the numbers from my data list. So I'll write down 9, 10, 11, and so on. And there you can see I've got the whole data list written down. The second column is going to be the mean. Remember, that's X bar, minus each of these values in the data set. So I'm going to take the 9 that I got over here on the right side for the mean. I'm going to take that 9. I'm going to subtract all of the data points away from 9. So that means I would have 9 minus 9, which is 0. And then I would have 9 minus 10, which is negative 1. 9 minus 11 is negative 2, and so on for the entire data set. And it doesn't matter whether you do mean minus the data point or the data point minus the mean, and I'll explain why when we finish this column as to why that doesn't make a difference. So then we would have the mean of 9 minus 6, which is 3, 9 minus 9 is 0, 9 minus 11 is negative 2, and so on through the entire data set. And there's the completed data set after taking the mean minus each of the data points. The third column is going to be the square of the second column. So whatever the second column is, we're going to square each of those so that we would have 9 squared, which is, or excuse me, that should be a 0. That should not be a 9. Let's fix that. So that means that would be 0 squared, which is 0. Negative 1 squared is 1. Negative 2 squared is 4. And we would do that for the entire data set by squaring all of the numbers. So I'll do that quickly here. And that's the square of the third column. See, and all of this was considered to be step 2 from the list that we did up here. Find the square of the difference between each of the data values and the mean. Step 3, find the sum of all the values in step 2. So we've got this third column. We're going to add all of those together. So when you add 0, 1, 4, 9, 0, add all of those together, you should get 52. The fourth step, divide the sum of the numbers of the values of the set of the data in. This value is the variance. So we're going to take that 52. We're going to divide that by how many values are in the data set, and that's 15. 52 divided by 15 is about 3.46 repeating. Now you can round that to 3.47 if you would like, but I'm going to go ahead and just leave it as 3.46 repeating in my calculator. This is the variance, and the symbol for variance is sigma squared. Sigma squared is the variance. Variance is used in other theories and regarding statistics, but we're using the variance to help us define the standard deviation because the fifth and the final step is to take the square root of that number. So I'll take the square root of 3.46 repeating, and when I take the square root of that, I get, if I round to the nearest hundredth, I get about 1.86. This is the standard deviation. This is the answer I'm looking for, which is abbreviated sigma, which is that cursive looking O. Right here is the standard deviation. So a high standard deviation indicates that the data is spread out very widely. A low standard deviation means it's very close to the mean. And I think you could say this one's pretty close to the mean. I think there's only a couple of numbers that stray away from more than 2 points away from the mean. You've got a 6 and a 5, but all the numbers are pretty close to the mean 9. So we would consider this to be a low standard deviation. We can also use standard deviation to compare data sets. Miguel plays golf at the Redstone and Memorial Park golf courses. Compare the means and standard deviation of each of Miguel's scores. So we're going to do a standard deviation for each of these data sets separately. So we do have to find the mean first. So that means to find the mean, we're going to add all of the data points together for Redstone. So add everything together. When you add everything together, you should get 803. And there are 10 data points. So we'll take 803 divided by 10. And that's going to be 80.3. So this has a mean, or X bar is going to equal 80.3. We're going to use that mean to help us find the standard deviation. So I draw my 3 columns. The first column is just my data set, so 81, 78, 79, and so on. And there's the rest of the data set. Second column is going to be the mean minus each of those points. So it's going to start out with 80.3 minus 81, and that is negative 0.7. And then you would have 80.3 minus 78, and that's going to be positive 2.3. Then 80.3 minus 79, that's going to be 1.3. We do that for all of the points in the data set. And then there's that second column. And then the third and the final column is we're going to square the second column. That's what x bar minus x squared means, is we're squaring the second column. So negative 0.7 squared is going to be 0.49. 2.3 squared is 5.29. 1.3 squared is 1.69. And we do that for every number in the second column. And that's what our third column is going to look like. Then we're going to add that entire column of numbers together. And when we add the third column together, we get 220.1. We're going to divide that by the number in the number of pieces of data we have. So we take 20.1 divided by, there are 10 pieces of data. That gives us 2.01. That's the variance, but we're interested in finding the standard deviation. So now we're going to take the square root of 2.01. That's going to give us the standard deviation, and that equals about 1.42. So that is the standard deviation of his scores at Redstone. Now we're going to do the same thing with Memorial Park. So to find the mean of all the data in Memorial Park, we're going to have to add all of those numbers together. And when we do that, we get 829. Then we divide that by the 10 pieces of data. We get a mean of 82.9. So the x bar for this column is 82.9. Then we create our three-column chart for this one. So our data points in the first column. So there's our data points in the first column. Then we're going to take the mean that we found, and we're going to subtract the mean minus each of the data points. So we'll start out with 82.9 minus 84, and that is negative 1.1. We'll have 82.9 minus 79, and that is 3.9. 82.9 minus 86 is negative 3.1. We'll do that for each of those data points. And so that is that set of data, that column. Everything was subtracting from the mean. And now we're going to square that column. So negative 1.21 squared is positive 1.21. When you take 3.9 squared, you're going to get 15.21. So we're going to square all of those numbers. And there's the rest of that column. Finally, we're going to add all of that column together. So when you add that entire column together, you are going to get 156.9. We'll take that 156.9, divide it by the number of data points, which is 10, and that is 15.69. That is the variance. And then we're going to take the square root of that number, and that will finally give us our standard deviation. So the square root of 15.69 is approximately 3.96. So that's the standard deviation of that set of numbers. And then finally, it says to compare the means and standard deviation of each set of Miguel's scores. So we can look at the means. The means of Memorial Park is actually a little bit higher than that of Redstone. But the big story will be the standard deviation. So if I make a quick comparison of the means, I could say the means of Memorial Park is higher than the mean of Redstone. But the standard deviation at Memorial Park being higher than that at Redstone indicates that he is much less consistent in his golfing at Memorial Park than he is at Redstone.